Hello everyone, welcome to Simple Math for You again, and we are solving compound inequalities part 2. أهلا بكم من جديد في Simple Math for You، وسنكمل اليوم حل المتباينات المركبة الجزء الثاني. Let's solve the real life application. مسائل من الحياة. Store signs. In Randy's town, all standalone signs must be exactly 8 feet height. When mounted atop a pole, the combined height of the sign and a pole together, the total height must be less than 20 feet or greater than 35 feet, so that they do not interfere with the power and the phone lines. Write a compound inequality to represent the possible above ground height of the poles X. So if the pole height is X, and we know that the height of standing alone sign is 8, the combination of them, we are adding the heights together such a way that they should be either less than the 20 or the same height will be greater than 35. So this is the translation of the situation. How can we solve them? We will solve each one separately. This will be x less than 20 minus 8, which is 12, or the other one, x more than 35 minus 8, which is 27. So the solution will be x less than 12 or x more than 27, where x is the height of the pole as well. If you want to graph the inequality, we will put the 12, open circle at the 12, 27, open circle at 27, because there is no equal signs there. And we have x less than, so that to the left of 12, or more than 27, which is to the right. So we have shaded area to the right, shaded area to the left. So this is the solution. Actually, our solution should not start by negative infinity. It should start at 0, because 0 is the initial height. The initial height will be 0, yani everything will be above the ground. We will not have the pole below the ground. We will not have anything below the 0. So the height starts by 0 until 12, and this can be extended to infinity. So this is the solution. 0 to 12 or greater than 27. Now, in this question, we are going to write the compound inequality corresponding to the graphs shown here. This is opposite to what we were doing before. Now, as you see here, we have some overlapping regions like this one, and this one, and this one, where we have here another non-overlapping region. For your information, if it is overlapping, then it must be combined with and. It might be combined with and. Most probably it will be combined with and. So in this case, we can simply say that the solution, as we are describing the solution, we can say that it's x more than -3, and because it is the intersection, x less than or equal to 3, because here it's closed. Or we can write x in the middle between -3 and 3, including the 3. So simply we can write it this way. Here we have the same thing, x more than or equal to 1, less than or equal to 4. Easy. For this one, we need to mention the or, because it is to the right or to the left. So we have to separate them. So we will say that it is x more than 3 or x less than or equal to 0, corresponding to this one. For that one, x is more than or equal to -2, less than or equal to 3. It's very easy. In a minute, you can solve 4 questions at the same time. Now, let's see here. We are translating the verbal sentence. راح نترجم ونحل. A number we will assume the number x decreased by 2, so it's minus 2, as is at most على الأكثر. على الأكثر means what? Means less than or equal to 4, or the same quantity, which is x minus 2, is at least 9, so at least على الأقل, so it should be more than or equal to 9. We have two inequalities to be solved. And they are combined with OR. So we'll put the 6 and the 11, close circle at 6, close circle at 11. X less than or equal to 6, so it's to the left to 6. More than or equal to 11, it's more than or equal to 11. So this is the solution. We can say that solution, we can write it in a set form. X such that X is less than or equal to 6 or X more than or equal to 11. Just list the solution. Perfect. The sum of a number and 3, so a number, let's say n plus 3, is no more than 8. So it can be less than or equal to 8. Or the same quantity more than 12, more than only. So it's greater than only without equal. And we will solve as usual. 8 minus 3 is 5, or n greater than 12 minus 3 is 9. So our solution will be n such that n is less than or equal to 5 or n more than 9. Perfect. Now, this is a good question. Which value of x is not a solution of this compound inequality? مين اللي مش solution؟ لا يصلح لأن يكون حل. So we don't have other choice now except solving. لازم نحلهم. So we have here. I'm listing them again. And I will solve. This is the first inequality. The second inequality, taking the 7, remember I put the negative x, 3 minus 7 is minus 4, divided by minus 1, switch the sign of the inequality, so it will be 4. So we have two inequalities. 2, open circle at 2, and less, 4, close circle at 4, and more. Now let's see where is the solution here. The solution is either more than or equal to 4, less than 2. Let's see, check one by one. The 0. Is the 0 in our solution? Is the 0 in this region? Is it or not? It's or, right? So it is more than or equal to 4. So is it in the solution area? Yes, it's somewhere here. Yes, so it's correct. Is 2 included? 2 is open circle here at 2. So 2 is not included, so it's not a solution here. 4, is it included? Yes, 4 is there's a closed circle, دائرة مغلقة, so 4 معانا included. 5 is somewhere here, it's in the shaded region, so yes. So the solution for this, you can choose what? You can choose the 2. 2 is the only number here from the list that is not a part of our solution. Perfect. And with that, we are done with part 2. See you in the next lesson. Thank you for watching and see you later. إلى اللقاء.